Today we're taking a look at section 3.5 on analyzing arguments with Euler diagram. An Euler diagram actually was the precursor to the Venn diagram, so they are very similar in nature. First of all, we need to talk about what we mean by an argument. An argument, we're not talking about a verbal disagreement in this case. We're talking about a logical argument, the type of argument you would present in court if you were a lawyer. An argument is valid if the fact that all the premises are true forces the conclusion to be true. An argument that is not valid is said to be invalid or a fallacy. Below we have an example of an argument. And you'll notice there are three statements. We have all math classes are hard. That's premise number one. Math 151 is a math class, so that's premise number two. We see the conclusion is separated from the premises by a line, and sometimes you will see therefore with three dots. Sometimes you'll see the three dots being used as therefore. Other times you'll just see it stated like our book does it without the therefore. So therefore math 151 is hard. So the question is this a valid argument? So what we do to analyze an argument with an Euler diagram is that we make an Euler diagram for the first premise. We add an Euler to the Euler diagram for the second premise, and then we look at the argument. It's valid if and only if the conclusion is true for every possible diagram that illustrates the premises. And just to give you some ideas of what some of the illustrations might be, this would be for all A are B. And the way I tell students to remember, all is small circle. Whatever is referred to, all books or all students or all cats, all dogs, whatever is called all, that is the part that is the small circle. Okay, so that's one way. Second, sometimes they'll say no A or B, so in that case, this would illustrate no A or B. Sometimes it will say, let me see if I can move down just a little bit. Sometimes it will say some A or B. This would also illustrate some A are not B. So this is some A or B, some A are not B. Okay, so what we want to do is consider the very first argument that I had here, which was all math classes are hard. So in that case, all is small, so that would be math, all math classes. And the big circle is hard. So all math classes are hard. All right, Math 151 is a math class. Okay, so this little X here represents Math 151. All right, and that's the only way we could draw this particular diagram to represent the two premises. Are we forced to conclude that Math 151 is hard? Well, it's inside the math classes, which is inside the hard, so yes. That would be a valid argument. Okay, let's try another one. All GCC students have cars. So, all right, all GCC, so this is GCC students have cars. Wendy has a car. Okay, it's possible Wendy could go there or there. We have really two choices for Wendy. Therefore, Wendy is a GCC student. Well, inside the little circle she is, but out here she's not. So this one's invalid. And it's invalid because we've thought of a case, in this case the one outside, is the one that makes it invalid. Okay, let's look at our last one. Some students study for the test, so we'll draw premise 1. Students study for tests. George is a student, so George could go there or there. We really have two choices. Therefore, George studies for the test. Again, this is like the last one. If he's in this area of intersection, yes, he does study for the test. But if he's in this one, that makes it invalid. And all we have to think of is one case where it's invalid, makes the entire argument invalid. Okay, so the next thing you want to do, this is a rather short lecture, so you want to make sure you take a look at the sample problems that I will record before you do the online homework.